Dear students, earlier classes we did centroid, in-center, section formula. Based on that, some questions. Now, finding the line equation, plane equation, point of intersection of lines, point of intersection of line and the plane, point of intersection of the planes. This concept is very important in your competitive examination point of view. We have seen line represented by the L equal to 0 represent the line, pi represent the plane. First find the line equations and plane equations in the vector method. Vector equation of the line passing through a vector point A bar and parallel to a vector B bar is R bar is equal to A bar plus TB bar, where T is a scalar. I will repeat, vector equation of the line passing through a vector point A bar and parallel to a vector B bar is R bar is equal to A bar plus TB bar, where T is a scalar. That scalar may be any real number. In order to find this line equation, now we define O be the origin. Consider a line passing through a vector point and this line is parallel to the given vector B bar. Let L is equal to 0 be a line passing through vector point, a vector point A bar and parallel to B bar vector. We consider a line passing through a vector point A bar and parallel to the vector B bar. Define the origin, may be on the line or outside the plane. Consider L equal to 0 be a line, O be the origin. So, this line passing through a OA vector A bar and this line is parallel to a vector B bar. That equation we are going to find. L is equal to 0 be a line passing through a vector point A bar and parallel to the vector. This is vector point, that is a vector. In order to prove this one, we use it to apply our geometry, locus method. Take a point P. Let OP bar is equal to R bar be a point on L equal to 0. You take a point P. OP bar is equal to R bar. Let OP bar is equal to R bar be a point on the line L equal to 0. How is this line? This line passing through a vector point A bar parallel to B bar. P is a parametric point we took on this line, and we are getting the line equation in terms of the point form known as parametric equation. That is L is equal to 0 be a line passing through A bar and parallel to B bar. Clearly indicates that AP bar, earlier I told you, joining two vector points a vector will be formed. The vector AP bar will be parallel to B bar. It clearly indicates locus of point P. Locus of point P is AP bar, the vector AP bar is parallel to B bar. When AP bar is parallel to B bar, earlier classes it was explained to you, when two vectors are parallel, one vector can be written as lambda times of other vector. As AP bar is parallel to B bar, the vector AP bar can be written as lambda, any scalar, T times of B bar, because these two are parallel vectors. As we expressed in the position vector, it clearly indicates that OP bar minus OA bar is equal to T times of B bar, or moreover R bar minus A bar is equal to TB bar. Therefore, the vector equation of the line will be R bar is equal to A bar plus TB bar. This is the equation of the line passing through a vector point A bar and parallel to B bar. Vector equation of the line passing through a vector point A bar and parallel to the vector B bar. Remember, this is a parametric equation. What is a parametric equation? Your line is constructed by many points, and expressing every point of this equation with the help of the A bar and B bar is called parametric point equation. Parametric equation is nothing but point equation. Parametric equation of the line. This is a point equation. If this point equation expressed in the Cartesian form with the help of x, y, z, you will be getting the algebraic complete equation, parametric point. And on eliminating the parameter, we will find the algebraic equation. And in the place of A bar, if the origin itself, if you put, one note you can mention here, the vector equation of the line instead of A bar passing through the origin, and parallel to B bar is in the place of A bar replaced by origin, then it becomes parallel to B bar is R bar. R bar is equal to this A bar will becoming null vector TB bar. This is the vector equation of the line passing through the origin and parallel to B bar, that is R bar is equal to TB bar. In the place of A bar we replace it by the origin. The vector equation of the line passing through two vector points, earlier passing through a vector point and parallel to B bar. Now we are finding the line equation passing through two vector points, that is, consider let L is equal to 0 be a line passing through two vector points A bar and B bar. The difference earlier, it was passing through a vector point and parallel to B bar. Now I took a line which is passing through two vector points A bar and B bar. Now consider O be the origin. O is the origin. Define a line L is equal to 0 be a line and origin somewhere. Origin. We took a line which is passing through two vector points A bar and B bar. I wanted to find the equation of this line in terms of A bar and B bar. For that again you define a parametric point. Let OP bar is equal to R bar be a point on L is equal to 0 line. Take a point here or here somewhere. OP bar is equal to R bar, a parametric point. So clearly it is noticed that APB will be collinear. It indicates the points APB are collinear. They lies on L is equal to 0. Can you apply the locus condition for this point P? What is the locus condition? APB will be collinear. Earlier definition we have discussed, points are said to be collinear if they lies in the same line or parallel lines. As APB lies on the same line, apply the collinearity condition. What is the collinearity condition? AP bar is equal to some constant times of AB bar. As they are collinear, locus condition is APB collinear points. So you can write AP bar is equal to, In the place of lambda, I wanted to put t into AB bar. As these three vector points A, P, B are collinear, one vector can be written as scalar times of other vector. So, AP bar is equal to t times of AB bar, where t is a scalar. Expand by using the position vector. AP bar can be written as OP bar minus OA bar is equal to t times of OB bar minus OA bar, and we took OA bar equal to A bar and OP bar is equal to R bar and OB bar is equal to B bar. That is, R bar minus A bar is equal to t times of B bar minus A bar, or moreover R bar is equal to A bar plus t times of B bar minus A bar, or it further can be simplified as R bar is equal to 1 minus t times of A bar plus TB bar. This is the vector equation of the line passing through two vector points A bar and B bar. So, in the previous problem or in the previous concept, we did line passing through A bar parallel to B bar is R bar is equal to A bar plus TB bar. Now, here line passing through two vector points A bar B bar, line passing through two vector points A bar B bar is R bar is equal to 1 minus t times of A bar plus TB bar. This is the line passing through two points and passing through a point and parallel. Remember, these two line equations are parametric, in the sense point equation. We took an arbitrary point on this line and applied the locus condition. Then we got the line equation passing through 2 points. Now, how to express the parametric equation into the Cartesian equation? Consider, either you may take the first line or second line, expressing this parametric into the Cartesian form. Let A bar is equal to A1, A2, A3, a point of the vector, and B bar is equal to B1, B2, B3, which is parallel. Expressing this parametric equation into the Cartesian form, R bar is equal to Xi bar plus Yj bar plus Zk bar. Consider a line passing through A bar and parallel to B bar. This one will be the parametric equation converting into the Cartesian form. That is, the line equation is R bar is equal to A bar plus TB bar. Substitute in terms of x, y, z. X times of I bar plus y times of j bar plus z times of k bar is equal to A1 I bar plus A2 j bar plus A3 k bar plus t times of B1 I bar plus B2 j bar plus B3 k bar. Component wise, already we have discussed that I, j, k will be the linearly independent vectors. So, it further can be written as x times of I bar, y times of j bar, z times of k bar is equal to A1 plus TB1 times of I bar plus A2 plus TB2 times of j bar plus A3 plus TB3 times of k bar. Equalate component wise and eliminate t. That is, x minus A1 divided by B1 is equal to y minus A2 divided by B2 is equal to z minus A3 divided by B3 is equal to t. This one we called as the Cartesian equation of the line, that one will be the parametric. When the equation of the line is considered in the parametric, can be converted into the Cartesian form, and if the Cartesian form is given, you can convert into the parametric form. Equation of the plane. Consider one plane and finding the equation of the plane. Let O be the origin. Consider OA bar is equal to A bar, OB bar is equal to B bar, OC bar is equal to C bar, 3 points which lies in a plane. Finding the vector equation of the plane passing through 3 vector points A bar, B bar, C bar. Define the origin. You draw one plane, pi is equal to 0 be the plane, be the origin somewhere, and this plane passing through 3 vector points A bar, B bar and C bar. Origin will be somewhere. Consider a plane which is passing through 3 vector points A bar, B bar, C bar. To find its equation, you take the parametric point P somewhere, P. Let OP bar is equal to R bar be a point in the above plane. Joining these points, vectors will be formed and they are coplanar. So, clearly indicates that AP bar, AB bar, AC bar are coplanar. These 3 vectors are coplanar. The vectors AP bar, AB bar and AC bar will be the coplanar. That is the locus condition apply for this plane. Earlier classes we have discussed that if 3 vectors are coplanar, one vector can be expressed combination of other 2 vectors. As AP bar, AB bar, AC bar are coplanar, so AP bar can be written as x times of AB bar, or you may take s times of AB bar plus t times of AC bar, where S, T are scalars. As AP bar, AB bar, AC bar are coplanar, expressed the first vector linear combination of other 2 vectors with the scalars S and T. And if you expressed in the position vector form, it will be OP bar minus OA bar is equal to S times of OB bar minus OA bar plus T times of OC bar minus OA bar. Or moreover, R bar minus A bar is equal to S times of B bar minus A bar plus T times of C bar minus A bar. Separating the A bar, B bar, C bar vectors, we noticed that R bar is equal to A bar plus SB bar minus SA bar plus TC bar minus TA bar. Or moreover, R bar is equal to 1 minus S minus T into A bar plus SB bar plus TC bar. This is the vector equation of the plane passing through 3 vector points A bar, B bar, C bar. Remember, this is also a parametric equation. Earlier classes also I told you, what do you mean by parametric equation? Point equation. We took a point in the plane, applied the locus condition for this point, we got the plane equation. What are S comma T? Where S comma T will be the scalars. And a constant. One thing you have to remember, to form a line equation, just now we have seen R bar is equal to A bar plus TB bar, line passing through A bar. To construct a line, one parameter is enough. To construct a plane, 2 scalars are required. They are S and T. In this above plane also, if it is passing through the origin, you may put origin in the first position. Therefore, you can write one note, vector equation of plane passing through origin B bar and C bar is in the place of A bar replaced by the origin. The equation becomes R bar is equal to SB bar plus TC bar, where S and T are the scalars. Remember, plane is constructed by the 2 scalars, line is constructed by 1 scalar or 1 parameter, 2 parameters. And one more thing we have to remember that these all the equations which we are going to discuss, they are parametric. Point equations. Finding the equation of plane passing through vector point and parallel to the other 2 vectors. Second formation of the plane equation. Consider O is the origin, pi is equal to 0 be a plane passing through OA bar is equal to A bar, OB bar is equal to B bar, 2 points, and parallel to a vector C bar. Consider one plane, deriving the equation of the plane which is passing through two vector points A bar, B bar and parallel to a vector C bar. Take one plane, pi is equal to 0 be the plane represented by pi. O is the origin. OA bar is equal to AA bar and OB bar is equal to BB bar, 2 points in the plane, and this plane is parallel to a vector C bar. That parallel vector you may draw here or here anywhere. Now, in order to find this plane equation, again we will take a parametric point P in the plane. Let OP bar is equal to R bar be a point in the plane. Okay. And how is this plane? The plane which is passing through vector points A bar, B bar and it is parallel to C bar. Correspondingly, an equal vector I wanted to draw here in the plane equation. So, clearly we noticed that again AP bar, AB bar, C bar will be coplanar. Draw a parallel equal vectors into the plane, applying the locus condition on this parametric point. So, AP bar, AB bar, C bar are coplanar. Again you apply the coplanarity condition. What is the coplanarity condition? One vector can be expressed combination of other two with the scalars. So, you can write AP bar is equal to S times of AB bar plus T times of C bar, where S and T will be the scalars. On expanding we noticed that AP bar minus OP bar minus OA bar is equal to S times of OB bar minus OA bar plus T times of C bar. Further it will be R bar minus A bar is equal to S times of B bar minus A bar plus TC bar, or it can be written as R bar is equal to A bar plus SB bar minus SA bar plus TC bar. Therefore, the equation of the plane passing through two vector points A bar, B bar and parallel to C bar is R bar is equal to 1 minus S into A bar plus SB bar plus TC bar. This is the equation of the plane passing through two vector points A bar, B bar and parallel to C bar. What are S comma T? S comma T will be the scalars. Again, in the place of A bar if you put the origin, that will become R bar is equal to SB bar plus TC bar. Remember, this equation of the plane is also parametric, point equation you may say. Just now we did equation of the line passing through A bar and parallel to B bar, equation of the line passing through two vector points A bar, B bar, equation of the line passing through origin and parallel to B bar, equation of the plane passing through three vector points A bar, B bar, C bar. Next we did vector equation of the plane passing through origin B bar and C bar, and we did vector equation of the plane passing through a vector point A bar and a vector point B bar parallel to C bar. In the plane, the last equation, vector equation of the plane passing through a vector point A bar and having B bar and C bar as a parallel vectors, that constant. O be the origin. We are giving, always we are defining the origin means giving a position to the vector, position of the vector. Pi is equal to 0 be a plane passing through a vector point A bar and having B bar, C bar as parallel vectors. According to this construction, we will draw a plane equation. Pi is equal to 0 be a plane, and O be the origin, may be outside or inside the plane, and this plane passing through A bar vector point and having B bar C bar as a parallel vectors. I took the plane pi and it is passing through a vector point A bar B bar. So, to find this equation of the plane, we will draw two equal vectors in the plane, C bar B bar, equal vectors drawn into the plane pi is equal to 0. Consider a parametric point P. Let OP bar is equal to R bar be a point in the plane, the plane which is passing through A bar parallel to B bar C bar. Apply the locus condition on this parametric point P, then we will get the plane equation. So, to apply the locus condition clearly indicates that AP bar, B bar, C bar will be coplanar. The vectors AP bar, B bar, C bar are coplanar. Earlier also we have discussed, three vectors are coplanar means one vector can be expressed linear combination of other two vectors with the help of the scalar uniquely. So, you can write AP bar is equal to S times of B bar plus T times of C bar, where S and T will be the scalars. Earlier also we have discussed, plane is constructed by two parameters, line is constructed by one parameter. In order to get the parametric equation, expand. AP bar can be written as OP bar minus OA bar will be is equal to S times of B bar plus T times of C bar, or OP bar is R bar minus A bar is equal to SB bar plus TC bar. Therefore, equation of plane is R bar is equal to A bar plus SB bar plus TC bar. Vector equation of the plane passing through a vector point A bar parallel to B bar C bar is R bar is equal to A bar plus SB bar plus TC bar. Again here also if you put the origin, then it becomes R bar is equal to SB bar plus TC bar. This is the parametric equation of the plane. Problems based on this concept. Before going to start the problems, you may be asked to find line equation, plane equation, or then two lines are intersected, L1 is equal to 0, L2 is equal to 0. The point of intersection of two lines is a vector point. In order to get the point of intersection of lines, equalating their R bar vectors, in the sense at their intersecting point both lines will have same point. This is the point of intersection of two lines. When a line and a plane are intersected, L is equal to 0 be a line intersected with pi is equal to 0 plane, L equal to 0 and pi equal to 0. So, this is the point of intersection of a line and the plane. The point of intersection of plane and line is a vector point. One point, both of them will be coincident, that is the point of intersection of line and the plane. At one point these two, then how to identify that lines will be intersecting or not intersecting, and uniqueness, check the uniqueness of the lines, then you will find the point of it. If the two lines are parallel, then there is no point of intersection, they does not satisfy the uniqueness property. If they satisfy the uniqueness, then we will find the point of intersection. Next, the point of intersection of two planes, consider pi 1 is equal to 0 and pi 2 is equal to 0, two planes. The point of intersection of two planes will be a line. For example, this is the first plane, pi 1 is equal to 0, and this plane is intersected with other plane, 𝜋2 is equal to 0. So, the point of intersection of these two planes will be a line, L is equal to 0. Point of intersection of two lines is a point, point of intersection of line and the plane will be a point, and the point of intersection of two planes will be a line. So, in the line equation, plane equation, we will find this type of problems. Find the vector equation of the line passing through a vector point 2I bar plus j bar minus 3k bar and parallel to the vector I bar plus 2j bar plus k bar. Find the vector equation of the line passing through a vector a bar and parallel to b bar. So, given that the vector point a bar is equal to 2I bar plus j bar minus 3k bar, and the parallel vector b bar is equal to I bar plus 2j bar plus k bar. We are finding the line equation, L is equal to 0 be the line, it is passing through a bar and parallel to b bar. Just now we did a proof, the vector equation of the line passing through a vector point a bar and parallel to vector b bar is r bar is equal to a bar plus tb bar, that is r bar is equal to a bar first vector 2I bar plus j bar minus 3k bar plus t times of b bar will be I bar plus 2j bar plus k bar, where t is the scalar. Better separate I bar, j bar, k bar component wise. So, your r bar can be written as 2 plus t times of I bar and plus 1 plus 2t times of j bar plus minus 3 plus t times of k bar. This will be the equation of the line passing through a vector point a bar and parallel to b bar. To convert this above line into the Cartesian form, let r bar is equal to xi bar plus yj bar plus zk bar express. The above line can be written as xi bar plus yj bar plus zk bar will be is equal to 2 plus t times of I bar, 1 plus 2t times of j bar and plus minus 3 plus t times of k bar. Earlier also we have discussed ijk will be the non-coplanar and they are linearly independent. As point wise if you equate, you notice that x minus 2 divided by x is equal to, x will be is equal to 2 plus t, y is equal to 1 plus 2t and z is equal to minus 3 plus t. When we expressed into the Cartesian form, x minus 2 by 1 is equal to t and this is y minus 1 divided by 2, that is equal to z plus 3 divided by 1. This will be the Cartesian form and this is the parametric form of the line equation passing through a bar and parallel to b bar. Find the equation of the line passing through two vector points a I bar plus j bar plus k bar and b I bar plus j bar minus k bar. Find the equation of the line passing through two vector points a I bar plus j bar plus k bar and b I bar plus j bar minus k bar. Take given that the vector points a I bar plus j bar plus k bar and the point b I bar plus j bar minus k bar. First you assume just now we did. The vector equation of line passing through two vector points A bar and B bar is R bar is equal to 1 minus t times of A bar plus t B bar, where t is a scalar. You consider one line L is equal to 0 and it is passing through A bar and B bar. Define the origin, O be the origin. The vector equation of the line passing through two vector points A bar and B bar. That is R bar is equal to 1 minus t times of I bar plus j bar plus k bar plus t times of I bar plus j bar minus k bar. Better separate I bar, j bar, k bar component wise. R bar is equal to 1 minus t plus t times of I bar plus 1 minus t plus t times of j bar and plus 1 minus t minus t times of k bar. This is t cancel, cancel, R bar is equal to I bar plus j bar 1 minus 2t times of k bar. Equation of the line passing through two vector points A bar and B bar. Find vector equation of plane passing through three vector points I bar minus 2j bar plus 5k bar minus 5j bar minus k bar and minus 3i bar plus 5j bar. Find the vector equation of the plane passing through three vector points I minus 2j plus 5k, minus 5j minus k and minus 3i plus 5j. Just now we derived the vector equation of the plane passing through three vector points A bar, B bar and C bar is R bar is equal to 1 minus S minus T into A bar plus SB bar plus TC bar. This is the vector equation of the line passing through three vector points A bar, B bar, C bar. Substitute. R bar is equal to 1 minus S minus T into A bar, I bar minus 2J bar plus 5K bar plus S into B bar minus 5J bar minus K bar plus T into C bar minus 3I bar plus 5J bar. The vector equation of the plane passing through three vector points. Better separate I bar, J bar, K bar component wise. So, the above vector R bar can be written as 1 minus S minus T minus 3T times of I bar plus minus 2 plus 2S plus 2T minus 5S plus 5T times of J bar plus 5 minus 5S minus 5T minus S and plus 5 plus into K bar. That is R bar is equal to 1 minus S minus 4T times of I bar plus minus 2 plus 7T minus 3S times of J bar plus 5 minus 5T minus 6S times of K bar. This is the vector equation of the plane passing through three vector points A bar, B bar and C bar. Find the point of intersection of the line joining the pair of points A 6A bar minus 4B bar plus 4C bar and B minus 4C bar. Finding the point of intersection of two lines, a line passing through AB and other line passing through CD, C is minus A bar minus 2B bar minus 3C bar, and D is A bar plus 2B bar minus 5C bar. Finding the point of intersection of these two lines AB and CD. So, this is line AB and this is line CD. We are going to find their point of intersection. L1 is equal to 0, L2 equal to 0. This is the point of intersection. Primary thing you have to notice that when two lines are intersected, first of all they must be coplanar lines. If one line is considered in one plane, another line is considered in the other plane, their point of intersection not possible. Primary thing, the lines must be coplanar lines, then we will go for the point of intersection. And one more thing, if the lines are parallel, then also the point of intersection can't be found. So, first we will find the vector equation of the line passing through A bar B bar, that is L1 equal to 0. Then we will find the vector equation of the line passing through C bar D bar, that is L2 equal to 0, then go for their point of intersection. Check the coplanarity and point of intersection. Okay, right. Let L1 is equal to 0 be the line passing through A bar B bar, that is R bar is equal to 1 minus T times of B, A bar plus TB bar. Just now we derived, you called first one. The vector equation of the line passing through two vector points A bar B bar is R bar is equal to 1 minus T into A bar plus TB bar. Just now we derived that also. That is R bar is equal to 1 minus T into A bar, 6 times of A bar minus 4B bar plus 4C bar plus T into OB bar minus 4C bar. We took the line passing through A bar B bar, and where T is a scalar, on separating coefficient wise, R bar is equal to 1 minus T times of 6 into A bar, or if you take A bar here common, R bar is equal to 6 minus 60 into A bar and coefficient of B bar plus minus 4 plus 4T into B bar and coefficient of C bar plus 4 minus 4T minus 4T into C bar. That is R bar is equal to 6 minus 60 times of A bar plus minus 4 plus 4T times of B bar plus 4 minus 80 times of C bar. This is the first line equation passing through A and B. Now, we will find the line equation passing through C and D, then we will go for the point of intersection. So, equation of line passing through C bar and D bar is R bar is equal to 1 minus S into C bar plus SD bar. Do not use same parameter, because S and T will be different parameters, so that the point of intersection and T, if you take same T, the coincident will be happen. To avoid this one, take different parameters. So, R bar is equal to 1 minus S into C bar. C bar is minus A bar minus 2B bar minus 3C bar plus S into D bar. D bar will be A bar plus 2B bar minus 5C bar. Again separate A bar, B bar, C bar component wise. So, your R bar is equal to minus 1 plus S into A bar and plus B bar component wise minus 2 plus 2S, minus 2 plus 2S and plus 2S into B bar plus C bar, that is minus 3 plus 3S, minus 3 plus 3S minus 5S into C bar, or moreover that is R bar is equal to minus 1 plus 2S, minus 1 plus 2S times of A bar plus minus 2 plus 4S times of B bar plus minus 3 minus 2s times of c bar, second line. We calculated the first equation of line AB bar, then we calculated the equation of line CD bar, equalating to find point of intersection, of AB bar and CD bar, equalate both the vectors. R bar is equalated to R bar for their point of intersection, that is 6 minus 60 times of A bar plus minus 4 plus 40 times of B bar plus 4 minus 80 times of C bar is equalated to minus 1 plus 2s times of A bar plus minus 2 plus 4s times of B bar plus minus 3 minus 2s times of C bar, equalating, check the coplanarity as well as point of intersection. Okay. So, it will be 6 minus 60 will be is equal to minus 1 plus 2s, that leads 60 plus 2s, 60 plus 2s minus 7 is equal to 0, you called it is equation A. 60 plus 2s minus 7 equal to 0. B bar coefficient wise, minus 4 plus 40 is equal to minus 2 plus 4s. This implies 40 minus 4s, 40 minus 4s and minus 2 minus 4, that is minus 2 equal to 0, called equation B. 40 minus 4s and minus 2 equal to 0. C bar component wise, 4 minus 80 equalated to minus 3 minus 2s, that is 80 minus 2s and minus 7 is equal to 0, C equation. 80 minus 2s minus 3 minus 4. To check the coplanarity, go for the point of intersection of A and B, substitute in the C. If it is substituted, they are coplanar, uniqueness. If they are not substituted, they are non-coplanar. Then solving A and B, solving for A and B, now you can solve t divided by coefficient of t, that is minus 4 minus 28, t divided by minus 4 minus 28 minus s divided by minus 12 and minus plus 28 and 1 divided by minus 24 and minus 8. So, t divided by minus 32 is equal to s divided by 28 minus 12. 28 minus 12 will be is equal to 6, 16 minus 16 is equal to 1 by minus 32. T divided by minus 32, s divided by minus 16, 1 divided by minus 32. So, we got that t is equal to 1 minus 32 by minus 32 and s is equal to minus 16 by 32, that is 1 by 2. Okay. Substituting s and t in the third equation, 8 times of 1 minus 2 into 1 by 2 minus 7, 2 ones are cancel. So, 8 minus 8 equal to 0. So, this s and t satisfies the third equation, therefore, they are coplanar. The above lines are coplanar lines. So, point of intersection also calculated, uniqueness also satisfies. To get the point of intersection, you put t in the first line equation or s in the second line equation. Okay. Substituting t in the first line equation or yes, because already it is removed, take, put s is equal to 1 by 2 in the second line, substituting s in the second line. Therefore, point of intersection of lines r bar is equal to, as we substituted s here, that is minus 1 plus 2 into 1 by 2 times of a bar plus minus 2 plus 4 into 1 by 2 times of b bar plus minus 3 minus 2 into 1 by 2 times of c bar. R bar is equal to, here 2 cancel, this is 0 and 2 ones are cancel, that is 0. 2 1s cancel, minus 4 into C bar. Therefore, the point of intersection of these two lines will be minus 4 C bar. Okay. We calculated equation of the line, equation of the plane, point of intersection of the lines.